Okay, so anybody have any issues? Nobody? Nobody have any issues? What?
Can you do 14?
I can try. Come on now, this is just basic algebra. The formula for area of a trapezoid is the average of the bases times the height, correct? So you are going to write down 164 is equal to 1/2. The two bases added together are 32.8. Do you agree with that?
Yes.
Times the height, which is x.
Oh,
Come on now, 164 equals 16.4x.
okay.
You agree with that?
Yeah.
So x was what? I'll help
okay.
you, 10. What? 26. The length of the design is 27-inch. So I'm assuming that's the design, correct? So Mr. Haggerty used 16 congruent rhombi shaped tile to design the midsection of the backsplash area above the kitchen sink. The length of the design is 27 inches and the total area is 108 square inches. Correct? So does everybody agree that's 27, that pink line that I just drew? All right. So now how many tiles are there? 16, right? Does that make sense? And so my question is, how much would each tile, the area of each tile would be how much? Come on now, this is not that hard. How many tiles are there? And the total area of all the tiles is what? So then each tile would have an area of, man, you guys are slow today. With calculators, it's taking you this long. What?
Same, I got 6.75.
So if you take 108 and you divide it by how many? 16, right? So what's 108 divided by 16?
6.75.
6.75. So we know the area of 1 is 6.75. Do you agree with that? Oh, that's the answer to A already. That was hard. I can see why that was a problem. Everybody agree? Now find the length of each diagonal. Well, we know this is 27, correct? So how many rhombi does that go through? 6. So diagonal 1, we could say, is equal to what? How much? I didn't hear you still. Somebody said 4.5. I don't know if she's correct. And some of you are like, well, I don't know how she got 4.5. Then you should ask. What?
How did she get 4.5?
I know, but come on. How many? What's the pink line? What's the pink line?
The diagonal.
One diagonal. Well, what's its length?
27.
And how many diagonals does it go through? How many rhombi does it go through?
6.
So what would be the length from here to here? It's kind of like that total area. Right? So what are we missing now? Diagonal number what?
2.
Diagonal number 2 is a big question mark. What's the formula for area of a rhombus? Help me.
1/2.
1/2. Diagonal 1 times diagonal 2. What's the area of one rhombi? What is it? Yeah, you guys, come on now. I'm not going to do all the work. What's one diagonal? So what's the other diagonal? That's the thing we're missing.
3,
How much?
3.
All right, guys, I'm not, I don't think that was that hard. Especially A. Okay. 30. It's a parallelogram, correct? Anybody? What's the answer?
Oh, what was there?
How do you do it?
Question.
Is the question.
I don't know.
Okay, so this one was maybe a little bit more challenging. Yes. Anybody? What's DC? Let's go with that. 15, right? Anybody have a problem with that? What's BC? So my question is, DCB and ADB, are they the same triangle? They congruent triangles. Come on now, guys. Come on, come on, come on. It's not hard. Is that true? They congruent triangles.
Yeah.
Right. Okay. So last chapter, we learned something. We learned area of a triangle is what? Oh, well, man. I mean, I don't even, there's so many good ways of doing this. Okay. I was going to suggest if you didn't know, we could calculate an angle and do 1/2 AB sine C. But I just recognized that this right here is a what? Is the right triangle, correct? So can we calculate that area? Come on, guys, we can do this. You got to think better. What is that area? What is this area? Come on, guys. What's the area of the highlighted, the one that I just highlighted? And some of you are using a calculator. What's that area? What?
15x.
Someone else, please. Numerically, should be able to look, everybody should be able to look at that and just say, obviously the answer is 54. Right? Come on. What is that area? The area of this triangle right here, what is it? 54. Not because I said it's 54, but because you should know it's 54. How is that area 54? Somebody tell me how I got 54. 9 times 12 divided by 2. That's a formula we just learned. Does everybody agree with that? Some of you, I don't know. Come on, I know it's Friday and I'm trying to sign no homework, but we got to do better. So this area right here of the highlighted is what again? I already forgot. What is it? 54. Did we agree that the triangle on the top is the same as the triangle on the bottom? So what would be the area of the top triangle? All right, now we're participating. That's 54. So what is X? I got you. What's X? How did you get that?
54 divided by 15.
That's how you find the area?
Yeah.
Is just
No.
divide the height by the base, or divide the area by the base, that gives you the height?
Yeah. And then you multiply by 2.
Right, come on now. That was good. All right, almost great. Area equals 1/2 base times height. 54 equals 1/2 the base times the height is unknown. Does everybody agree with that? So what does that come out to be? The height, which is also X. I should have put X there as what?
7.2.
Anybody else get 7.2?
Yeah.
Is everybody okay with that? Okay, now that's one cool way of doing it. All right. There's another cool way of doing it. All right, which I've seen on the SAT a couple times. So this is why I kind of want to show you this also. What's the formula for area of a parallelogram again? Area equals, what is it? Base times height. Right? Now, what is the base and height of that parallelogram? What's the base and height of that parallelogram? Or I should say, what's one base and one height? 15x, thank you. All right. Now, what's another base and height of that parallelogram? That's why this is hard to see. Yes, sir. 9 and 12. Everybody see that? From here. Ooh, wait a minute. Do that. 15x equals 9 times 12. How much?
7.2.
7.2. Was that the same answer? Yeah, that was sneaky. All right, that was kind of tricky. All right, so that's another way. Base and height. All right. There's 2 bases and 2 heights to every parallelogram, just like there are 3 bases and 3 heights to every what? Triangle. So in this case, you could just have said base times height is equal to base times height and go from there. All right, that was actually a good question. All right, I'm glad we reviewed that one. All right, the rest of it's just kind of plugging numbers in. Does everybody agree with that? All right, does anybody have any last thing before we try to get the homework done so we don't have any homework? All right, let me pause real quick and collect. Yeah, 5th graders know the area of a circle. So what's the area of a circle? Yeah, area equals pi r squared. All right, I like to leave things in terms of pi. All right, we're going to say the area is like 12 pi or 8 pi or 7 pi. We're not going to put in 3.14. Not really going to use the calculator pi button very much. All right, now the next part is called a sector of a circle. All right, now a sector, I can just draw it out right here. Let's say this right here, all right, is the sector that I'm referring to. A sector is just a piece of the circle, all right, kind of like a piece of pie. That would be considered a sector, all right. Now, let's say, for example, this angle measure right here was X degrees. Can somebody please tell me what would be the area of that X degrees? Go ahead.
X divided by 360 is pi r squared.
That's all there is to it. It's just a fractional part of the area. It's just a fractional part of the area. What do you mean by that? Like, for example, I'll say to kids, if I draw a circle, try to draw a circle. If I draw a circle, and then I were to say to you, what's the area of half the circle? You would just simply say pi r squared divided by 2. If I said, what's a fourth of the circle? You would just simply say pi r squared divided by 4. Well, why is it 1/2 and why is it 1/4? Because a quarter of the circle is what? 90 degrees. So it'd be 90 out of 360. Half is what? 180 out of 360. So there is no difference. And I never understood why people aren't familiar with that. Or it's a basic formula. If you want the whole area, it's pi r squared. If you want a piece of the area, it's whatever angle you cut out of what? Out of 360. That's all there is. All right. Now, with that being said, all right, let's take a look at number 1. Correct answer for area is what? No, you were not using a calculator, guys. Come on. Area is what? 25 pi inches squared. All right, number 2, that is the what? Diameter. So the area would be 100 pi meters squared. Everybody good with that? What?
Oh, wait, never mind.
All right. Now, again, if it's necessary, now we're having trouble with 9.5. Just go ahead and type in 9.5, square it, and what are we coming up with? What?
Pi is just squared.
I'm agreeing. Nothing to it. All right. Now, here we go. Number 7. The area of a circle is 153.9 square centimeters. Find the diameter. Now, this has been rounded. All right. So obviously, we're going to have to round. So remember, 153.9 equals pi r squared. So you take 153.9. You have a pi button on your calculator. Just hit 153.9 divided by pi. And r squared is approximately what? I said r squared is approximately what? You took 153.9 and divided by 9. What is it? 48.987. Do you agree with that? Anybody? What?
How do you get
Tanner, come on now. It's 153.9 equals pi r squared. How do I solve for r squared?
You gotta divide by 5.
Wow, check that on the,
I just don't know where the pi button is.
you have to look for it. I'll show you. It looks kind of like this. That's the pi button. That's the symbol. No, that's the problem. All right, that's the problem. People, look for yourself. It's a symbol on the calculator. Look for the symbol on the calculator. And now, after you have r squared is equal to 48.987, you need to take the what? Square root. So r is roughly, it looks to me close to what? 7. Is everybody okay with that? Anybody have any issues? All right. And then if you found the radius to be 7, then thank you so much. The diameter then would be what? 14 centimeters. Okay. All right, anybody have any questions with that? Given the area, work your way backwards, divide by pi, take the square root. Everybody knows that. Okay, now the fun starts. Number 11. All right, if we're doing number 11, we have area of the shaded region is pi. What's the radius? 3 squared times what? No, times 45 out of what? 360. So now you're just doing 3 squared times 45 divided by 360. Math, enter, enter. I want it as a fraction. So my answer is
9
you should say it's 9 pi over 8. 9 pi over 8. And I'm totally fine with you just typing that in on your calculator. All right, leave pi in your answer. Leave pi in your answer. Anybody have any questions with how to use their calculator? What? How many degrees are we using? Out of how many? Right, that's the formula. I don't want you to worry about that formula. I just want you to say that's common sense. I'm using 45 out of what? 360. All right, now don't be confused on number 15, please. Everybody take a look at 15. So everybody can write down A equals pi. What's the radius? 10 squared times what? How much? 324 over 360. Now we do know that 36 degrees is 1/10, correct? This represents 1/10 of the circle, right? So the other one would represent what? We could have just done 9/10. And then we could have just said that's 90 pi meters squared. All right, that's how I'd hope you would think about it. 36 degrees is 1/10 of the circle. All right, so we need 9/10 of it. That's the shaded region. All right, yes, sir.
How do you get it? Like, how do you get from like that to like the final answer?
I did 10 squared times 9/10.
So
Isn't 10 squared times 9/10 90 pi? Is that, yeah, you see what I'm saying or not, Sebastian?
Yeah.
All right. Okay, I don't even have to read the question. So how many degrees would this be right there? 120, or you could just look at it and say they're asking for what? A what? A third of it. That's correct. A third of the area. 1/3 pi r squared. Somebody with me on that? All right, I think all that's easy. Find the area, find the area, find the diameter, find that. What is the area of each piece? The figure below shown. Okay, so let's look at 29. Red jump ahead to 29. All that other stuff was super easy. That's busy work. All right, this is the important part. The figure shown below is a sector of a circle. If the perimeter of the figure is 22, find its area. So how much is this right here? From here to here? Well, I just wrote it, so. That again is just the what? That's the radius, correct? So can someone please, come on now, this one's the hard one. All right, so please look up. So what is this length from here to here? Somebody please quickly tell me. What?
10.
10. Beautiful. That's 10. Come on, wake up. Is everybody agreeing that's 10? Tanner?
I'm so confused.
Tanner, the whole perimeter is how much?
Oh, wait, I didn't see that.
The whole perimeter is 22. So now is everybody good with that? Now, can someone tell me based off that what this angle is going to be? Everybody tell me. All right, let me give you a hint. It has to do with circumference. What's the circumference of the circle? 2 pi r. So the circumference of the whole thing would be what? Let's just say this, guys. Oh, man. Thank you, whoever said that. Here's my circle. What would be the circumference of that circle I just drew? No. I didn't say the area. I said, what is the circumference? Circumference of a circle, 2 pi r. So the circumference of the whole pink circle would be how much? 12 pi. Does everybody agree with that? But we're not using all of the circumference. We're using how many of it? 10 out of how much? Yes. So we're using 10 divided by 12 pi. All right, does everybody agree with that? Hello, does everybody agree? How many degrees in a circle? Right. So I used a fractional part of 360. So multiply that by 360. So everybody do that real quick. So everybody do 10 times 360. Divided by 12 pi. Now, to me, you should have just done 300 divided by pi. And what's 300 divided by pi? What? 300 divided by pi is 900.
I just put in what you said.
Oh, blame me. Okay, blame me. I appreciate that. All right, for your wrong answer, you're blaming me. Good idea. 10 times 360 divided by 12 pi. Figure that out. What is it?
95.492.
About 95.492 degrees. You can't know that, all right, unless you type it in on your own calculator. If you didn't get 95.492, you are doing something wrong on your calculator. It's easy to do something wrong. All right, because when I said divided by 12 pi, you just hit divided by 12 pi instead of dividing by parentheses 12 times pi. Is everybody with me? Please look at that and make sure he's correct. I said 10 times 360 divided by 12 pi, but he didn't put parentheses around the 12 pi. That's why he got the 900 or whatever. So you're dividing by a quantity, you need parentheses. All right, is everybody with me? That's 95.492 degrees. Everybody with me on that? All right, so now if I wanted to find the area of that, if I wanted to find the area would be what? Pi r squared times n over 360. What's the radius again? So pi times 6 squared times the answer that's on our calculator divided by 360. That was really hard, actually. That's the area of that sector.
Are the answers even like the 95?
Yeah, the 95.492. How much was it? Anybody else get 30?
Yeah.
And we would say 30 millimeters square. Is that bad? Everybody's good on that? All right, again, put a little star by that. Please look that over. I like that problem. That was really hard. What? Hurry up.
So like, how do you know to multiply 10 12 pi times 360?
Because, and that's a good question. All right, so I'm trying to get you to understand that 10 is a fractional part of the whole circumference, correct? You agree with me or not? So the whole circumference was what? The whole circumference is what?
12 pi.
Right? So I did 10 out of 12 pi. Do you agree with me?
Yeah.
So if I did 10 out of 12 pi, that's the fractional part of the circle that's being used for that arc. Does that make any sense?
Yeah.
Let me break it down like this though. Let's say I had this circle again, and let's say I wanted this, right? That is trying to be half of it, correct? So if I said the radius was equal to 6, and I said this was 6 pi, how many degrees is that? Arc. Well, what's the whole circumference?
So the whole circumference is like, it's like
It's good, 12 pi, right?
Yeah.
Because it's 2 pi r, right? I'm trying to listen. He's asking me a good question, and I'm happy that he's asking, because I'm trying to show you how I would figure this out if I had no idea, right? So I have a piece of the circumference, right? So I'm making up my own little problem to see if I understand it correctly. So I know the whole circumference is what? 12 pi of this made up problem. Do you with me?
Yeah.
Right. So now I said, okay, I know halfway around is 6 pi, correct? So do you understand what I'm saying now? So 6 pi out of 12 pi represents half of the circle. Do you agree?
Yeah.
And half of the circle is 180 degrees. So I knew that this was 180 degrees, right?
Right.
Now, let's just say this. Let's just say I did this from here to here now. I'm making a different arc, but I'm in a hurry. Let's just say that's 3 pi. How many degrees is this arc? Come on now, someone help him. That arc is 3 pi, tell him. Of course, 90, obvious. Why is it 90? Because what's the whole circumference? Well, no, but I'm asking you this question. What's the whole circumference? 12 pi. I just measured out how much? 3 pi. 3 pi over 12 pi represents what? 1/4 of the circle. 1/4 of the circle is how many degrees? 90. That's how I knew that was 90 degrees. Hey, you with me? Does that make sense now? Right. A fractional part of the circumference represents a fractional part of the degrees. Yes? You understand that now, right? All right. Like I said, that's a really more challenging than I had wanted it to be, probably. All right. That's hard. All right. Anybody else want me to say that again to make sure you understand it? And the reason why it's more difficult, if I were them making up this problem, I would have probably made this number here a better number so you could see it a little bit better. All right. Like I would have tried to use something that worked out evenly. All right. But besides the point, everybody look that over. All right. I like that. All right, now we have area of a shaded region. All right, for whatever reason, this is difficult for kids as well. So if I'm looking at number 30, I would like everyone to just say, obviously, the area of the shaded region is 324 minus 81 pi square feet, right? Obvious. Come on now. Who's going to help me out with that explanation? No, but what I want you to do is tell me how I knew that. I could not have said it better. Thank you so much. That's exactly correct. Come on, guys. Everybody should be able to look at that and say, that's just a square with a circle cut out. That is a square with a circle cut out. Do not make that more difficult. That's on a lot of standardized tests, and people just like, what? I never understood it. All right. So because this is a little bit more challenging, let's go ahead and check out 31. Everyone write down the area of that shaded region for number 31. Thirty more seconds. Ooh, we got an answer. Go ahead.
25 pi.
25 pi. That would be the area of the circle, yes. Tell him. Minus 25. You guys are smart. That was good. Obviously, it's 25 pi minus 25, correct? Right, because what's true about that triangle? What kind of triangle is it? Isosceles. Thank you for saying 45, 45, 90. So because of that, please stay with me. What is this length right here? Right, 10. I know what you meant. That's 10. Anybody have a problem with that being 10? Anybody have a problem with that being 10? Because to get from the leg to the hypotenuse, you multiply by what? You multiply by radical 2. And let's say you forgot that. We can throw down this 45 degrees right here. We can do a little trig if you want to impress somebody. So I agree with that. All right, but we know that's 10, correct? Which means the radius of our circle is what? Which means the radius of our circle is 5. So radius equals 5. Is everybody happy with that? So if my radius is 5, the area of the circle would be what? 25 pi. Now I have to subtract out the area of the circle or the area of the triangle. Now I'm happy with this explanation because it's helping you. Do you remember how to multiply radicals? Do you remember the formula for area of a triangle? All right, all these are little pieces that you have to remember. All right, so it's 1/2. The base and height are what? 5 radical 2, and you square that. Everybody's good? So how do we do 5 radical 2 squared? 5 times 5 today is, square root of 2 squared is, 25 times 2 divided by 2 is just what? 25. And that would be meters squared. All right, now remember, you're not supposed to just be writing down my answers. If I go too fast or you're not 100% sure, be brave. Everybody's good with 25 pi minus 25. That is another really good problem. All right, so let's have some fun with 32. Come on, this is the important stuff. Hmm. Ooh. I'm liking it, man. Go.
Is it 49 pi minus 24.5?
24.5 what?
Oh, millimeters.
Pi, right?
Oh, yeah, pi.
Right. I'm not saying that's correct. I'm just saying we have
Yeah.
to have right and then millimeters squared. Someone else want to help him? You're agreeing with that. Is that the answer? Right, because the radius of the circle is what? 7. So the whole thing is 49 pi. I'm really happy with that. All right, now we have 2 smaller circles, correct? And the radius of the smaller circle is 3.5. Is everybody good with that? And then you have to do 3.5 squared and then times that by what? Times that by 2. So is that 3.5 squared times 2? Is that 24.5? Wow, I'm good. All right, man. That's pretty nice. Now, does anybody recognize what is true about those 2 areas? This has always fascinated me when I had these types of things. What's 49 divided by 2? That's exactly half of the circle. That's exactly half of the circle. All right. I know it's kind of strange how it works out. I never could understand all those curves involved, and it cuts it exactly in half. All right. Very strange. All right. So now let's look at number. I think we're good with 33. All right. Let's try 34. Let's try 34. Quickly come up with that exact answer in terms of pi. Exact answer in terms of pi. Now, as we go down, you're supposed to be getting a little better. I know it's not easy for some of you. All right. So try a little bit. All right. Try. You might surprise yourself after a while. You keep trying long enough, you're going to get it. But you got to try. You got to do it yourself. And then as soon as you have it, let's go. Let's hear it. Let's not wait for everybody. Come on, I got to get to one more. Honestly, we should be done with this one. Anybody? Good.
Is this 9 pi times 50 over 360?
9 pi times, ooh, close.
Oh, wait, times 2.
Yes. Or you could just say 9 pi times
100 over
100 over 360. Perfect. Meters squared. So help me out with that fraction. Come on, people. I see some of you just sitting around kind of daydreaming. All right. Not ever lifting a calculator, not writing a pencil. Come on. I need help with that. I said, what's that answer?
7.853.
No, I want it as a fraction. What's the fraction? Leave pi in the answer. What is it?
I don't know.
9 times 100 divided by 360. Math, enter. If you don't feel like doing the math. No, it doesn't. 2.5 or 5 halves pi. 5 pi over 2. Don't use pi on the calculator. Do 9 times 100 divided by 360. Math, enter. What is that? Is that right? 5 over
Yeah.
2? And then we say meters squared. All right. The only one I want to do is on Monday. Make sure we do 37 and 38 on Monday. 37 and 38 on Monday. If you're having trouble, you don't know those, or you had not sure what we were doing, make sure you look those over. I want to do that. You can try it over the weekend if you want. Try 37, 38 over the weekend. I'm saying if you don't know how to do what we were doing, you should practice. All right. You were on fire today. I have to agree with that.